Welcome to physics class. In this video, I'm talking about scalar and vector quantity. But the aspect I'm going to talk about is the angle between the two acting forces. In my previous video, I have actually explained the algebra and the sum, or let me just say algebra sum and subtraction of vector quantity. If you haven't watched that video, kindly go back and watch the video right now. So the next aspect is the angle between the two acting forces. Suppose that we have force F1 and F2. We have force F1 and F2 acting at a specific angle to each other. Let's say force F1 and F2 are acting at angle 55 degrees to each other. Suppose we have angle, suppose we have another force F3 and F4 acting at angle 135 degrees to each other. Then how is the diagram going to be? How are we going to sketch the diagram? It's very simple. The first thing, one important thing that we actually need to note here is that whenever we have two forces acting at a specific angle or at a particular angle to each other, it can either be in two different cases. For example, it is acting as an obtuse, or let me just say acute angle, or we have the case to be as obtuse angle. So one thing is that if you're talking about acute angle, they are the one that they are between angle 0 degree and 90 degree. But if you are talking about obtuse angle, they are between the angle 90 degree and 180 degree. So if you look at this very well, force F1 and F2 are acting at angle 55 degree. That means the diagram is going to be in form of what? Of acute angle, right? Because acute angle is in between 0 and 90 degree, and our 55 lies between 0 and what? 90 degree. That means the diagram of F1 and F2 is going to be in form of acute angle, while the diagram of first F3 and F2 is going to be in form of what? Obtuse angle, because it lies between 90 degree and 180 degree. So now what we are going to do is that I'm going to sketch the diagram for F1 and F2, and I'm going to sketch another diagram for F3 and F4. Let's say our first F1 is acting along this side, right? It's acting along this side. Then we have the diagram like this. The diagram is going to be something like this. Say you have something like this exactly. Let's say this is actually angle 55 degree, right? F1 is acting with what? To F2. They both F1 and F2 are acting at angle 55 degree to each other. Then let's consider F3 and F4. Suppose F3 and F4 are acting at angle 135 degree. Then how is the diagram going to be? Is it going to be something like this, or is it going to be something more enormous than this? So let's go ahead and sketch the diagram. We are going to have the diagram to be something. It's going to be something like this, right? Then we have it like this, right? We have it to be something like this. The reason why I sketch the diagram here, I sketch it as this, and also the reason why I sketch this as this is that we all know that if F1 and F2 are acting perpendicular to each other, that means they are acting at angle 90 degree to each other, right? And we all know that angle 90 degree is specifically, or is basically something like this, right? But since this is angle 90 degree, and we know that our 55 is not up to 90 degree, if we set our compass, we are going to reduce this, and we are going to reduce this to somewhere here, right? Which is 55 degree, right? So that's the reason why I drew this one like this. Then the reason why I drew this one like this is that since everything here is 90 degree, then here I'm talking about this is actually 135 degree, right? That is angle. Our force F3 and F4 are acting at angle 135 degree. Since this is 135 degree, if you look at this very well, this is perpendicular, which is 90 degree. So since 135 degree is greater than angle 90 degree, that means I'm going to expand this hand towards the side, right? Which is this. So after that, if you look at these two diagrams very well, by the time I assume my imaginary line, let's say I assume imaginary line here, right? And also I assume my imaginary line to be here. Both of them are going to form a parallelogram, right? Similarly with this, right? By the time I assume both are going to form a parallelogram, right? So since both are actually, they actually represent a parallelogram diagram, what we actually need to consider here is that we need to consider the properties of parallelogram. And we have the three main characteristics of parallelogram angle or parallelogram, which is known as, for a parallelogram angle, the opposite sides must be equal. That is, the first case is that the opposite side are equal. That's the first case. The opposite sides are equal. The second case is that the opposite side must be parallel. Since we are talking about parallelogram, the opposite side must be parallel. The opposite side must be parallel. So after that, another thing that we need to have is that the third case is that the opposite angle are equal. The opposite angle are equal. So these are the three major, or let me just say three main characteristic of parallelogram. So whenever we have force F1 and F2 acting between 0 and 90 degree, just know that the diagram is going to be in form of acute. If they are acting between 90 and 180 degree, that's obtuse. So in that case, one major thing that you guys to note is that whenever we are talking about angle less than 90 degree, most of them are actually acute. If you are talking about angle greater than 90 degree, right, but less than or equal to 180 degree, they are actually obtuse angle, right? So now let's go ahead and name the angle. Let's just name this angle A, let's name this B, right? Let's name this our C, right? Let's call this C and let's call this D. Similarly, let's go ahead and name this E. Let's name this side E, right? Let's name this side F and this side G and this side H. So these three properties, I actually want to prove it, right? The opposite side are equal. That is, the opposite side must be equal, right? If this side is F1, then this side also should be F1, right? If this side is F2, then this side also should be F2. After that, let's move to the second case. If this side is F3, then this side must be what? F3. If this side is what? F4, then this side must be what? F4. So after that, the question says that the opposite side are parallel. The opposite side are parallel. Then how can we prove that? Listen, looking at this, if you look at this line and this line, they are parallel to each other. Looking at this side and this side, they are parallel to each other. This side and this side are parallel with each other. This side and this side are parallel with each other. The opposite angle are equal. Then, if the opposite angle are said to be equal, That means the sum of all the angles in a parallelogram must be equals to 360 degree. Exactly. That means in this case, this side, if this side is 90 degree, this side is 90 degree, this side is 90 degree, and so this side is what, 90 degree. Everything must be equals to what? 360. In the case of acute angle, since we said the opposite angle are equal, what I'm actually going to do in this case is that let's considering angle ADC and angle ABC. Exactly. We are considering this side ADC and ABC, right? So what actually happens is that we said the sum of all the angle in a parallelogram must be equal to 360. That means ADC plus ABC must be equal to what? 360 degree, right? So after that, what we actually need to consider in this case is that since we said ADC plus ABC must be equal to 360, but if you take note of this, looking at the characteristics or properties of parallelogram, we said the opposite side must be parallel. The opposite angle are equal. The angle here is what? 55, right? And the angle here also will be what? 55 degree. Since according to the law, or let me just say properties of parallelogram, the opposite angle are equal. That means the opposite angle here must be equal, right? Then I'm going to add this to be what? 360 then minus 55 degree, then plus 55 degree. Exactly. So here I'll be having it to what? 360 minus 110, which is 110. So here I'm having it to what? 250 degree. So one thing is that since angle ADC is equal to angle ABC, but the sum of angle ADC and ABC must be equal to 360, right? But we are only familiar with what? Angle A and angle C, but we are not familiar with angle B and angle D. So what will happen is that since both sides are equal and the opposite angle are actually equal, then the angle here that I'm having, which is what? Angle 250 degree, is going to be ABC, which is equals to ADC, equals to 250 divided by 2, right? Which is what? 125. Since I said my angle ABC must be equals to angle ADC, you know, by the time I split this into 2, that means I must have equal ABC and also ADC, right? So in this case, I'm going to split them. By the time I split them into 2, both of them, both B and D, they are going to have what? 125 degree. This will be 125 degree C, and also this will also be what? 125 degree. So after that, by the time you sum everything together, everything must be equal to 360, which means angle ABC plus angle ADC must be equal to 360 degree. So after that, what we actually need to understand here is that since we have everything to be 125 degree, that means if force F1 and force F2 are acting at angle 55 degree to each other, then the leftover angle, the rest of the angle is going to be what? Is going to be the sum of F1 and F2 minus 360. Then we are going to have what? Our B and D. This plus this minus 360 will give us what? B and D. Exactly. So after subtracting this from 360, we divide it by 2, which is what? 125. Then here is going to be 125, and here is going to be what? 125. Then let's consider the next one, considering angle, that's EFGH. Angle EFGH is also a parallelogram, right? But using the following law, the opposite side are equal. Exactly. This side F3 is equal to F3, F4 is equal to what? F4. The opposite side must be parallel. This is parallel to this. This is also what? Parallel to this. Then the opposite angle are equal, right? So after that, if this side is 135, this angle is 135, then this also must be 135 degree, right? So that's the third property. Since we are considering angle EFGH, right? So what actually happens here is still the same thing with what actually happens in the second case. That means our angle EFG plus EHG must be equal to 360 degree, which means angle EFG plus EHG must be equal 360 degree. But we are given angle E and angle D to be 135 degree. So what this actually means is that angle EFG plus EHG equals to 360. Then we are going to have our 360 degree to be, okay, 360 minus into brackets these two angles, which is what? 135 plus 135. Right? After that, we're going to have our 360 minus 270 degree, right? Then here is equals to 90 degree. Since we are dealing with F and H, then we go ahead and divide our angle 90 degree by 2, which is what? 45. It shows that this is actually angle 45 degree, and this side is also what? Angle 45 degree. So the first case is actually the case of the acute angle, and the second case is the case of the obtuse angle. To calculate the resultant force, now the resultant force of these two angles, of angle ABCD and also angle EFGH, to calculate the resultant force is taken to be the what? The diagonal of the parallelogram ABCD. And what I mean by diagonal is that it's just a line that is drawn from angle A to angle C, something like this, and this is taken to be what? Our resultant force. So resultant force is taken to be the, or let me put it like this: the resultant force of force F1 and force F2 is taken to be the diagonal of the parallelogram ABCD. And you guys should note that the diagonal is drawn from the point of intersection of force F1 and force F2, which is at this point. This is where our F1 and F2 intersect. So in this case, we are going to have the resultant force to be summed here. This is where our F3 and F4, this is where they intersect. So we are going to have our resultant force to be somewhere here. Right? These are our resultant force. These are resultant force in this case, and these are resultant force in this case. Suppose force F1 is equals to 10 Newton and force F2 is equals to, that's, let me just take it to be 12 Newton, right? Both F1 and F2 are acting at angle, let me just call angle, that's let me just say they are acting at angle 55 degree to each other, right? So now I'm now asked to calculate for the resultant force. It's very simple. So what I'm going to do is that angle 55 degree lies between 0 and 90 degree. Then I'll take my compass and set it, right? Then here I'm going to have the angle to be somehow like this, right? It's going to be like this. Then here is my what? My 55 degree. Then here is my what? Force F1. Here is my force F2. Then after that, let me just, my imaginary line is going to be here, right? Then I'm going to have it to be this. So after that, I'm having my force F1 to be here and force F2 is here. So don't forget that according to parallelogram law, right? The opposite side must be equal, right? And the opposite side must be parallel. The opposite angle must be equal. So if this is 55, then this will also be what? 55 degree, right? So after that, I'm going to take everything here to be the what? The resultant force, which is the intersection, the points at which F1 and F2 intersect each other. So this is going to be my what? My resultant force. So to calculate the resultant force can be calculated using our cosine rule. And to calculate the direction, you can use what? Sine rule. So what you need to know is that if you want to calculate for the resultant force R, you can use what? Cosine rule. And if you want to calculate for the direction, you can use what? Sine rule. Right? So that's just the two major keys that I'm having. So now looking at this, I'm going to calculate the what? The resultant force. But before I calculate the resultant force, since all this angle are taken to what? 55 degree, right? So if this is 55 degree and this is 55 degree, then what is going to be this and what is going to be this? That means since I know that the sum of all the angle here on a parallelogram must be equal to 360, then I'm going to have my 360 minus what? 55 plus what? 55, which is angle A, B, C, and D, right? A plus B plus C plus D must be equal to 360, right? But I'm giving A and C. That means I'm going to subtract this from what? 360. So therefore, here is going to be what? That's 250 degree. But I must divide it by 2 because of my B and D, right? Which is what? 125 degree. Right? So here I'm going to have to what? 125 degree, and here also is going to be what? 125 degree. The next thing is that using my cosine rule to calculate for the resultant force. And my cosine rule is given by what? Resultant force square equals what? Force F1 square, right? Plus F2 square minus 2F1 F2 cos D. I can actually use cos D. The reason why I'm using cos D in this case is that I can consider my A, C, and D. So I will redraw this diagram here so that I'm going to have it to be something like this, right? I'm going to have it like this, something like this, right? So this is the diagram, right? So here, this is my A, my resultant force, right? And my C. This is my what? D. Everything here is going to be 125 degree, right? So the angle here, since everything here is 55 degree, then I'm going to assume this to be what? My alpha, and this to be my what? Beta. But the sum of alpha and beta is 55 degree. So here I'm going to have alpha. After that, then I'm giving my angle C here. So what I'm going to consider now is that the major angle that I'm going to use to get my alpha or to get my resultant force R is angle D. But I'm going to calculate it using what? My R square, which is my resultant force. And the formula which I'm going to use is known as the cosine rule. So after that, what I need to know is that I need to find the point of intercept. The point of intercept here is actually, let's say this is actually my F1 and this is my F2. So the point of intercept is this side, right? So I can just mark this side to this side, right? Because my resultant force is taken to be the what? Is taken to be the intersection of force F1 and F2. Or you say the diagonal of this triangle the diagonal of angle, or you just say the diagonal of our parallelogram is taken to be the what? Resultant force. So here I'll be using this angle 125 degree. So using this angle 125 degree, I'm having my F1 to be what? 10 Newton and my F2 to be what? 12 Newton. Then let's go ahead and calculate this using cosine rule. So using cosine rule, R squared equals to, what I need to do now is that I'm going to simplify this. R squared equals, so let's go ahead and simplify. Our R squared is, that's, everything is 244, then minus into bracket 240 multiplied by this is going to give me minus 137.66, right? So here I'm going to have to be R squared equal, that's 244 plus 1, R equals to 244 plus 137.66. That should give me 381.658, which is my R square. Then my R equals to root of 381.658, right? Then my R equals to 19.53 Newton. It shows that the resultant force here is actually 19.53 Newton. To calculate for the direction, let me just move it up here. For the direction, I said we are going to use sine rule. The sine rule is taken to be AC, angle AC divided by sine D equal CD divided by what? Sine A, which is equal AD divided by what? Sine C. That's to calculate for the direction. So go ahead and use this formula to calculate for the direction and drop your answer in the comment box below. This is not the end of the video. I'll be releasing the part 2 of this video. I'll be doing the part 2 in a separate video actually. So in the separate video, I will solve different questions that deals with angle between the two acting forces. So this is the end of this video. If you find this video helpful, kindly click on the subscribe button and do well to share the video out with your friends. And also, don't forget to click on the notification button. Thanks for watching.